12 learners. Welcome to today's technical science lesson. My name is Lebohang and my setting is Teledi. This lesson is brought to you by the Gauteng Department of Education in collaboration with Saibono Discovery Center. So for today's knowledge area, we'll be focusing on mechanics, which has a total of 93 marks. And today's topic will be focusing on Newton's third law and momentum. Right, so just to remind you about the mark allocation for paper 1, we have your section A, which consists of 10 multiple choice questions, which has a total of 20 marks. And then we have either 8 matching items or 8 one-word items, which consists of a total of 8 marks. Then again, we have your section B, which consists of structured or long questions and has a total of 122 marks. And the total for paper 1 is then 150 marks with a duration of 3 hours. And again, just to elaborate on the topics to be covered in paper 1, we have your mechanics, which has a total of 93 marks and has a percentage weighting of 62%. Electricity and magnetism, which has a total of 33 marks and a percentage weighting of 22%. Then wave, sound and light, which has a total of 24 marks and a percentage weighting of 16% there. Right. So, so far, we are still under the topic of Newton's laws of motion. And so far, we have covered Newton's first law. And under Newton's first law, we then covered inertia and mass. Then we covered Newton's third law. And under Newton's second law, we covered, we used the formula F net is equals to ma, and we covered free body and force diagrams. And then again, we also covered acceleration. Okay, so for today, we are going to be talking about Newton's third law. And under Newton's third law, we are going to be covering the action-reaction pairs. Okay. So Newton's third law, it states that, and this is according to your examination guidelines. So it states that when object A exerts a force on object B simultaneously exerts an oppositely directed force of equal magnitude on object what? On object A. So if, for example, according to the blocks below, we have object A and object B there. Then Newton's third law is saying that when object A, so for example, if this block object A is going to exert a force, so let's say this force is then what is then F2 is going to exert a force on object B, so it is this box B. Then what is going to happen? Object B, so object B, the block B will simultaneously, that means that at the same time, it is going to exert a force on what? On object what? On object A. Then it says that simultaneously exerts an oppositely directed force of equal magnitude on what? On object A. So equal magnitude means what? It means that if object A is going to exert a force, let's say, for example, a force of 40 Newton on object B, so a force of 40 Newton on object B, then it means that object B will also exert a force of equal magnitude. So magnitude is what? Is the size. So A exerted a force of 40 Newton on B. That means that B will also exert a force of what? A force of 40 Newton, that is of equal magnitude. Equal magnitude means what? Exactly the same size. So it is going to be 40 Newton on A and then 40 Newton on what? On B as well, simultaneously. It means what? At the same time. Then we have action-reaction pairs. So it says that whenever two bodies interact with each other, the force exerted by the first body on the second body is called the action. So again, let's say we have the two bodies here. We have a block A and we have what? We have a block B. So it says the force exerted by the first body. So let's say the force of A exerted by the first body is therefore going to be called what? It's going to be called the action. And then it says the force exerted by the second body. So the second body in this case will be indicated by what? It would be indicated by block B. Then it says on the first body is therefore called the what? The reaction. Okay, so it says there the action and reaction pairs are equal and what? And opposite again in what? In direction. Okay, so which is also the same explanation as your what? As your Newton's third law. Right, so we are going to do this activity together. It says there, a woman and a man are standing facing each other on an icy frictionless surface. They are both on ice skates. The man then pushes the woman away with his hands with a force of what? Of 100 Newton. So this man is pushing the woman away with a force of what? With a force of 100 Newton. And then it says what? And then the woman, she then moves to the what? She then moves to the right. Right? Then the question here then says, how will the magnitude of the force exerted by the woman on the man compare with the magnitude of the force exerted by the man on the woman? So now what are they looking for? So initially they said that the man pushed the woman in which direction? Pushed the woman to the right hand side with his hands, and then what happened? The woman then moved to the right. Okay, so now the question is saying they are looking for how will the magnitude means what? The magnitude it means the what? The size. Okay, so it says how will the magnitude of the force, so they want to know the magnitude of the force or the size of the force that will be exerted by what? By the woman on the man. So it says by the woman on the man compare with the magnitude of the force that the man exerted on the woman. So now the question says you must write only bigger than, smaller than, or equal to. So it means that you need to explain this according to what, or think of it according to Newton's third law. So if the man is going to apply a force on the woman to the right, it means that the woman will also apply an equal force of what? Of 100 Newton to the what? To the left. So the woman will apply a force that is of equal magnitude. Equal magnitude means what? It means that the woman will also apply a force of what? Of 100 Newton in what? In the opposite what? Direction. So our answer for 2.6.1 will therefore be what? It will therefore be an equal to force. So our answer is equal to. Then 2.6.2, it says you must name and state the law that was used in question 2.6.1. So the law is therefore what? It is going to be our Newton's what? Third law. And then you are going to refer to your what? To examination guideline to write your what? To write your definition. So what's important here is that we need to what? We need to read and emphasize. So it says we must name. Name, that means that we are going to get what? We are going to get 1 mark for the naming. And then it also says that we need to state. So we're not only going to name, we need to name and say it's Newton's third law, and then we need to what? We need to state that law. So what does Newton's third law say? It says when object A exerts a force on what? On object B, and then object B simultaneously exerts an oppositely directed force of equal magnitude on what? On A. Okay. And then we are going to move on to momentum and impulse. So under momentum and impulse, we are going to be covering momentum. We are going to be covering the formulas of momentum there, mass and velocity as well. We are going to be covering the change in momentum, the formulas that we need to know in terms of the change in momentum, and then the law of conservation of linear momentum, Newton's second law in terms of the linear momentum there. We're going to be covering impulse and the types of collisions. Right, so according to your examination guidelines, under momentum, it says that we need to know how to define momentum as the product of an object's mass and its velocity. And then we need to describe linear momentum as a vector quantity with the same direction as the velocity of the object. Then we need to calculate the momentum of a moving object using P is equals to mv in the context of technology. Right, so we have a scenario here, and then it says a bullet when fired, small as it is, will do more damage than a brick if the brick was thrown. Okay, so we have a bullet, and you know that the size of the bullet is what? The size of the bullet is very small as compared to what? As compared to a brick. So it says here, a bullet when fired, small as it is, so it's an emphasis that a bullet is what? Is small. The bullet will do more harm than a brick if the brick was what? Was thrown. Then it says, however, if both the bullet and the brick were fired and thrown at the same speed, then the brick would do more damage than the bullet. So again, we are saying the bullet is smaller compared to what? Compared to the brick. So if you are to throw both the bullet and the brick at the same speed, what are we expecting? We are expecting that the brick would then do more damage as compared to the bullet. So it says, how does it happen that a lighter object does more damage than a heavier object? It says the impact or damage doesn't depend on the what? On the mass alone, okay, but rather on the mass of an object together with the what? With the speed at which the object is moving. So again, if you compare the bullet, we are saying the bullet is smaller than the what? Is smaller than the brick. So whatever impact that you are going to do with the bullet and the brick, it does not only depend on the what? It does not only depend on the mass of whatever object, but it depends on the mass and the speed. So both of them, it depends on the mass, and it also depends on the speed of the object. So it says, therefore, this quantity is therefore referred to as what? As momentum. Then it says here, define momentum as the product of an object's mass and what? And its velocity. Okay, so in symbols it says P is equals to what? mv, whereby the P is our momentum, and then the small letter m there is our mass in kilograms, and then the v is what? Is the velocity in meters per second. Therefore the two units of mass, which is what? Kilograms, and the unit of what? Of velocity, which is meters per second. They therefore give us the units of what? Of momentum, which is then kilograms meters per what? Per second. So going back to the definition there of momentum, it says you need to define momentum as the what? As the product. So mathematically speaking, when you speak of the product, then what are you saying? You are speaking about what? Multiplication. So you need to define a momentum as the product. So the multiplication between what? Between the mass and what? And the velocity. So the product of an object's mass and its velocity. Okay, then it says momentum is a what? Is a vector quantity. And then what did we say is a vector quantity? It means that it's a physical quantity which has what? Both direction, which has magnitude and what? And direction. So by magnitude, again, what do we mean? It has a size, and it will also have what? It is also going to have the direction. So it says momentum is a vector quantity. Then it says momentum is a vector quantity that has the same direction as the what? As the velocity. So what are they talking about? Meaning that from the same formula of P is equals to mv, whatever direction that you are going to have in terms of the velocity will therefore be the direction of the what? Of the momentum. So let's say that an object is moving to the right, maybe let's say at a velocity of 12 meters per second, so to the right. So after the calculation of your momentum, whatever direction that you have for your velocity will therefore be the direction of your what? Of your momentum. Then it says momentum is directly proportional to the velocity, provided that the mass remains what? Remains constant. Okay, so it says momentum is directly proportional to the velocity. So meaning that if your velocity increases, then what are we expecting? We are also expecting that the momentum will also increase. Again, if your mass increases, what are we expecting? We are expecting that your momentum will increase as well. So the momentum will be directly proportional to the velocity, and again the momentum will also be directly proportional to the what? To the mass of the object. Then in terms of the tips that you can use for momentum or linear momentum and impulse, you need to make sure that you read the scenario carefully and underline the keywords, or you need to collect the given data. Then it says here that you need to remember the velocity, momentum, change in momentum, and the average force are all vectors. Okay, and then what did we say is a vector again? We said it's a physical quantity which has both magnitude and what? And direction. Okay, then we always need to take direction into account. That is very important. Remember, we said that momentum is a what? Momentum is a vector, and it's going to take the direction of a what? It's going to take the direction of the velocity. Then we need to refer to the data sheet when carrying out the calculations. So remember, the data sheet will be given to you during the examinations. So you need to make sure that you know the relevant formulas that you need to use for whichever topic that you are dealing with. And then it says here you need to pay attention to the what? Pay attention to the mark allocation. Okay, then in terms of the formula sheet there, or the data sheet that will be given to you, and the identification of which formulas to use. So we are going to be using this one, which is the one that we just learned about now, P is equals to mv. And then we're also going to be using this one, F net change in time is equals to the change in the momentum. And then again, we'll be using this one as well to calculate the change in the momentum. So just make sure that even in class that your teacher gives you the formula sheet, so that whenever you are doing calculations, you can always refer to the formula sheet, and that you get used to using it, so that it will help you also to remember when you get to the examination. Now we are going to do the following example together. It says here, calculate the momentum of a 6 kilogram object moving at what? At 5 meters per second to the what? To the right. So you need to learn to do what? Data collection. So what is the first thing that we have there? They spoke of a 6 kilogram object. So immediately when you see the 6 kilogram object, what are they talking about? They are talking about the mass. So that's the first thing. We have the mass there. And then it says it is moving at what? At 5 meters per second to the what? To the right. So what are they talking about on this one? They are talking about the velocity. Okay. So then again, what are you going to do from there? You are going to refer to your formula sheet there, and then look for what? Look for the formula that you can use to calculate the momentum if you have what? If you have the mass and also the velocity. So what is the formula? Our formula is P is equals to what? Is equals to mv. Okay. Then so it's P is equals to mv. And then you need to learn now how to do what? How to substitute, right? So when we substitute, we are not going to be substituting the units in between, but rather let us substitute the units at the end, so for the final answer there. So what is the mass of the object? The mass of the object is given as what? Is given as 6 kilograms. And then it says it is moving at what? It is moving at a velocity of 5 meters per second to the what? To the right. So our velocity is given as what? As 5. So therefore you then take your calculator and multiply the 6 times 5. What does it give you there? Your momentum is therefore going to be 30. And then how do you write the units? The units are given. So you are given the units of what? You are given the unit of mass there. And then you are also given the unit of what? The unit of the velocity. So what are you going to do with those units? You are just going to combine the two units. And then what are you going to have? It means that you will have the kilograms, which is given, and what? And the meters per what? Per second there. So it's going to be kilograms, meters per what? Per second. Those are the units for what? For momentum. And then remember we said that momentum is a vector quantity, meaning that it will have magnitude, unit, and what? And the direction. So what was the direction for the velocity? The direction for the velocity was what? Was to the right. So therefore it means that the direction for the momentum will also be in which direction? To the right hand side there. So if you are to be marked on this, you would get a mark for the formula, a mark for the substitution, and then a final mark for the correct answer with the correct unit and the correct direction. Okay, so for number 2 there, it says calculate the velocity of the car if its momentum is what? Is 134 kilograms meters per second, and the mass is 234 what? 234 grams. Okay, so let us collect the data there. The first thing that we see there is that we need to calculate the what? We need to calculate the velocity. Okay, so if we are calculating the velocity, it means you need to remember the symbol for the velocity. Number 2, we are given the what? We are given the momentum. So the momentum there is given as 134, and the unit is kilograms meters per second. Okay, so The symbol for momentum is what is P, and then the symbol for the velocity is what is V. Then again, we are given the mass, which is 234 grams. 234 grams. So this 234, it represents the what? The mass. So what we need to learn again here is what is conversions. Conversions are very important, and you need to make sure that you learn all the relevant conversions that we are going to need. So we see that we have what? We have grams there. That means that we need to convert the grams to what? To the kilograms. And then how are we going to convert the grams to kilograms? So we are going to divide this by what? By 1,000. When we divide by 1,000, what do we get? We'll get 0.234 what? Kilograms. So I'm saying to convert from grams to kilograms, you are going to divide by 1,000. So when you take your 234 divide by 1,000, it will give you 0.234. Okay. Then what are we going to do from there? We are going to look at your formula sheet there and look for the formula of what? Of momentum. So what is the formula of momentum? It's P is equals to mv. Then what are we given? We are given the momentum there, which is what? Which is 134. And then what else are we given? We are given the mass. It was given in grams, but remember we had to convert it to what? To the kilograms. So when we converted, it gave us 0.234 multiplied by what? We are calculating the what? We are calculating the velocity. So therefore the velocity is unknown. So now we need to get rid of the what? We need to get rid of the 0.234, which is on the right hand side. What are we going to do? We are going to divide both sides by the 0.234, and then what do we have there? So on the right hand side, the 0.234 and the 0.234, they are going to cancel each other out. And then on the left hand side, what do you have? You have the 134 divided by 0.234. Then from there, you are going to punch that into your calculator to say this one divided by that one to get your what? Your velocity. So in this case, I am then getting 572, and then remember you need to round off to what? Round off to 2 decimal places. So the full answer that I'm getting there, it's 572,649.5. So we are going to round off to what? We are going to round off to only 2 decimal places. So therefore our final answer will be 572, what? This one, the 9 will change the 4 to a what? To a 5, so that we have 0.65 meters per what? Meters per second. So from the momentum, we were not given the what? We were not given the direction, but we know that the velocity is a vector quantity. So we are therefore going to say that the velocity is therefore the direction. We will say in the direction of what? So we'll say in the direction of what? Of motion, because we are not given the direction. But let's say if the direction was given at east, then our direction for the velocity would also be east. If it was west, our velocity would also be our velocity would also be the very same. Would be the very same as what? As that of the momentum. Okay. So also just make sure that you know how to round off your answers, because remember you are going to lose a mark if ever you don't round off properly. And also remember to round off to what? Remember to round off to 2 decimal places. Okay, then looking at example number 3 there, it says you need to calculate. So it says calculate the mass of an object So what are we looking for? We need to calculate the mass this time of an object with a momentum of what? With a momentum of 56 kilograms meters per second, which is moving at what? Which is moving at a velocity of 6.2 meters per watt per second. So calculate the mass of an object with a momentum. We are collecting our data now. Our momentum is what? Our momentum is letter P. And then moving at a velocity of what? Velocity is what? Is letter V. So what's the next step? You are going to use your formula sheet there and look for what? Look for the formula of what? Of momentum, so that you can be able to calculate your mass. What is the formula of momentum again? It's P is equals to mv. So let's have a look here. Are we given the momentum? Yes, we are given the momentum as what? We are given the momentum as 56. Are we given the mass? We are not given the mass. We are looking for the mass. And then are we given the velocity? Yes, we are given the velocity. What is our velocity? It's given as, let me put brackets there. It's given as 6.2. And then what are we supposed to calculate here? We are supposed to calculate the mass of the object. How are we going to calculate it? We need to divide both sides by the 6.2 so that we can get rid of the 6.2 on the right hand side. So we divide by 6.2 on the right and divide by the 6.2 where on the left hand side. So from there you are going to punch that into your calculator. Let me cancel this. So the 6.2 and the 6.2 on the right hand side are going to cancel each other out. And then what are you left with? I'm just going to write it on the left hand side so I can have more space there. You are left with the mass. So you're going to punch that into your calculator. The momentum of what? Of 56 divided by the velocity of 6.2, and that will give you your mass. So our mass is therefore 9.03 what? 9.0322. So remember again, you need to learn to round off to what? To 2 decimal places. So from there, what are you going to have? You are going to have 9.03, because the 2 will not change the what? The 2 will not change the 3. So this is then 9.03 what? Kilograms, right? So moving on to example number what? Moving on to example number 4 there. It says you need to calculate the what? Calculate the momentum. What is momentum again? Momentum is a P there of a 1,500 kilogram car. So what is this kilograms? The kilograms represent the what? It represents the mass that is driving at 90 kilometers per hour due east. Okay, so in this one, what are we given? We are given the velocity, and then we are also given the what? We are also given the direction. Remember we said velocity is a what? Velocity is a vector quantity. That means that it has what? It has magnitude. Magnitude is what? Is the size. So it has magnitude and what? And direction. So there's the magnitude is 90, there's the units, and then there's the direction. Okay, so the next step is for you to look at the what? The next step is for you to look at your formula sheet and look for the formula of what? Look for the formula of momentum. What is the formula of momentum? It's P is equals to mv. Okay, then what are we looking for? We are looking for the momentum. What is the symbol of momentum? It's P. Next we check, do we have the mass? Yes. Do we have the velocity? Yes. But the velocity is given as what? As kilometers per hour. So what is it that we need to do? Before we do our substitution, let us do what? Let us do a conversion. So we are going to convert this kilometers per hour to what? To meters per second. So how do we do that? We will then say 90 divided by what? By 3,6, and then you punch that into your calculator. It will give you what? 25 meters per what? Per second. That is your new what? Velocity. Okay, so you have your mass there of what? Of 1,500. So we are now substituting 1,500 multiplied by what? Multiplied by a velocity of what? Of 25. So you are going to use your calculator. 1,500 multiplied by 25, and I'm getting 3,700. And then what are the units of momentum? We are going to get them from the question itself. The unit of momentum, you have mass, which is measured in what? Kilograms, and then you have the velocity, which is what? Meters per second. So from there, what are you going to do? You are going to combine the mass and the velocity. The mass and the velocity is what? Kilograms meters per second. Then because this one now is what? Is your momentum. What is the direction of the momentum? Remember we said the direction of the momentum will be the same as the direction of what? Of the velocity. So in this case, we said what is the direction of the velocity? The direction of the velocity was given as east. That means that the direction of the momentum will also be what? Will also be east. So we'll have 37,500 kilograms meters per second. What? Due east. And that is your momentum. So again, just to go over the calculations again, or the steps. So what is the first thing that you're going to do? You are going to collect your data for the question, right? Then from there, you check to see if you need to convert anything. And then from there, you are going to go onto your formula sheet to look for the formula. And then you are going to substitute whatever variables that you have there. And then from there, you need to calculate your answer. You need to give it a unit. And then if ever you are dealing with a vector, then you are going to give it what? You are going to give it the direction, right? So now I'm going to give you about 2 minutes just to do this one, and then we can then continue from there. 2 minutes for this activity. Welcome back, learners. So if you have any questions, you can send your questions to the following WhatsApp number 063 508 1301. I will repeat the number for you. So if you have any questions, you can send your questions to the following WhatsApp number 063 508 1301. Okay, so let us have a look at the activity together. It says the magnitude of the momentum of a bicycle is given as what? As 19,3. So the magnitude is what? The magnitude, remember we said it is the size. So the magnitude of the momentum. So momentum, we know that we are dealing with which symbol? We are dealing with symbol what? Symbol P. So this momentum is given as 19,3 kilograms meters per second. Then it says you need to calculate the magnitude now. So the magnitude is the size of the momentum of the bicycle if it had the following. Number one, if it had the same mass and was moving at twice the speed. Okay, so let's analyze it together. So how do we analyze again? It means that we need to look at what? We need to look at the formula sheet. So P is equals to what? P is equals to mv, according to the formula that we have learned so far in terms of what? In terms of the momentum. So it says if it had the same mass, so that means that the mass is not changing and was moving at twice the speed. So here's the key words here. Same mass and was moving at what? At twice the speed. So twice means what? We have twice the velocity. So what will be the magnitude of the what? Of the what will be the magnitude of the new momentum? So if the mass remained the same, that means that if it was whatever value, let's say the mass was 2 kilograms, the mass will therefore remain the same. But let's say the velocity, for example, was 2 meters per second. The velocity is now moving at twice the speed. So what do we need to do? It means that we multiply whatever that we have as the velocity by what? By 2. What will be the magnitude of this? So what will be the size of the what? Of the new momentum? So what are we going to have there? We have 2 times what? Times mv, which is your what? Which is your momentum. 2 times mv, what was the initial momentum given as? It was given as 19,3. So from there, what are you going to do? We are going to multiply the 19,3 with the 2 to give you what? 38,6. So with that 38,6, we must remember to write what? You must remember to write your units, which is then kilograms meters per second. So on this one, they only said they wanted the magnitude. So the magnitude means what? It's the size of the new momentum. Then looking at number 2 there, it says if it had twice the mass and was moving at the same speed. So what are you going to do? Again, you need to go back to your formula sheet and look for the formula of what? Of momentum. Okay, because they want to know the magnitude of momentum, which is P, and then you can see that they're talking about the mass and the what? And the speed. So the mass and the speed, then it means that we are talking about what? Momentum. So this time, what are they saying? They're saying if it had twice the speed. So twice the speed means that we are going to have what? We are going to have 2m. Twice the mass means that we are going to have 2m and was moving at the what? At the same speed. So same speed means that the what? Means that the velocity will remain the same. So we're not going to put any numbers there because the velocity will remain the same. Then what do we have? We have a 2 outside of the brackets and what? An mv. What is mv again? mv is your mv is your momentum. So if you're going to multiply the 2 and the 19.3 again, what are you going to have? You will have the 38.6 kilograms meters per what? Meters per second. So again, they said we must give the what? They said we must give only the magnitude. So you'll give the magnitude and then you'll also write the what? You'll also write the unit. So the next one, number 3, says half the mass. So we need to calculate again the magnitude of the momentum if we have half the mass and if this bicycle was moving at what? At twice the speed. So again, we are looking for momentum. We are given mass. We are given what? We are given the speed, and then we need to look for the magnitude of momentum. What are you going to do? Go back and look at your formula sheet and look for the formula of what? Of momentum, which is what? P is equals to mv. So it says what? If we had half the mass, so there is the mass, we now have half the mass, and then with the speed of what? Moving at twice the speed. So twice the speed means what? We'll then have 2v, so twice the speed. And then if I want to move my numbers to one side and letters to one side, it will then be half multiplied by what? Multiplied by 2, and then all of that multiplied by what? Multiplied by my mv, which is therefore my momentum. So mathematically then we'll say half multiplied by 2 over 1 and then multiply by the mv, which is your momentum. So again, the 1 and the 1 will cancel each other out. The 2 and the 2 will cancel each other out. What are you going to be left with? You are left with the mv, which is your momentum. And the value of the momentum will therefore be what? 19.3 kilograms meters per second. So it means that in this case, the momentum will therefore not change. Okay, so just make sure that you have a look and also practice a lot of these types of questions whereby you're not given the actual values, but you are just told the factors with which the mass and the speed will therefore will increase or decrease. Then next we are going to have a look at the change in what? The change in momentum. So remember, momentum was only the letter what? The letter P. So but then when we speak of the change, then we are going to have the symbol here and what? And the letter P. Then it says it is the difference between the final momentum and the what? And the initial momentum. So how do you indicate your final momentum? You'll indicate it using PF. How do you indicate your initial momentum? You will indicate it using PI. And then again it says that it is dependent on the change in what? The change in the velocity. Okay, so change in the velocity, again it will mean what? Final velocity minus what? Minus the initial velocity. And then the change in momentum is what? Is the final momentum minus the initial momentum. So again, what we need to know there is that the units, the SI units, are what? Are kilograms. Where is that coming from? It's coming from the mass, kilograms, and then the meters per second means what? It means that we are talking about the velocity. So a combination of the mass again and the velocity, they therefore give us a unit of what? Of kilograms meters per what? Per second. So in this case, it means that the SI units for what? For the change in momentum and the SI unit for the momentum are the same. So again, it says here the formula is therefore change in momentum is equals to the mass into the final velocity minus the initial velocity. And then in symbol is the change in momentum is equals to P final minus P initial. Then when you break it down, you will have mv final, which is what? Which is your final velocity minus mv initial. Or else you can write it in this way to say you have m into what? V final minus the V initial. So again, just to repeat there, we said that the mass will be measured in what? In kilograms, and then we said that the velocity will be measured in meters per second. Okay, then we have an example here. So it says a car with a mass of 990 kilogram moving at a horizontal velocity of 20 meters per second to the right, hits a wall and bounces horizontally backwards at a velocity of 5 meters per second. Okay, so what is the first thing that we are going to do? We are going to collect our data. Then what do we have? We can see that we have a mass there of 990 kilograms. We can see that we have a car which is moving at a horizontal velocity, with a velocity of what? Of 20 meters per second. In which direction? To the right. So we have a car. This car is moving to the right at what velocity? At 20 meters per second. And then this car, it hits a wall. And then after hitting a wall, it does what? It bounces horizontally. Where? Backwards at a velocity of what? Of 5 meters per second. Okay, so initially 20 meters per second. After bouncing back, 5 meters per second. So after hitting the wall, when it moves backwards, 5 meters per second. What is this? This is the velocity. This is the initial velocity, and this is the final velocity. Okay, number one, there says you need to calculate the momentum with which the car hits the what? Hits the wall. So what are we going to take into consideration when we do this momentum calculations? We need to take into consideration the direction. So let's have a look at this one. Initially, it was moving at 20 meters per second. In which direction? They said to the right. Okay, and then after it hit the wall, it was moving at what? At 5 meters per second. So they said it moved backwards. So if it moves backwards, if initially it was traveling to the right, if it moves backwards, it means that the the direction will therefore be to the what? The direction will therefore be to the left. Okay, then from there, calculate the momentum with which the car hits the wall. What are you going to do? You have collected your data there, and then from there, what are you going to do? You go back to your formula sheet and look for the formula of what? Of momentum. So what do we have in terms of momentum? We have P is equals to what? P is equals to mv. So the momentum with which the car is hitting the wall, it means that we are moving in which direction? To the right. Okay, so if we are moving to the right, it means we are calculating our initial what? Momentum. Okay, so if we are calculating our initial momentum there, what do we have as our mass? Our mass is given as what? Our mass is given as 990. So m is our mass, 990, and then our velocity is given as what? Our velocity is given as 20. So you are going to punch that into your calculator. 190 multiplied by 20. What does it give you? 19,000 what? 19,800 kilograms what? Meters per second. Where do you get the SI units? You will get the SI units from the combination of the mass and the velocity, and it gives you what? It gives you the SI units of momentum. So in which direction? Remember, momentum is a vector quantity, which means what? It will have both magnitude and what? And direction. So now we have written the magnitude as well as its unit, and then we need to write the what? The direction. And then what did we say? We said the momentum will take the direction of what? Of the velocity. What was the velocity of this 20 meters per second? It was to the right. What was the direction of the velocity? Sorry, it was to the what? To the right. So we are therefore going to say in which direction? To the right. Number 2, the momentum with which the car leaves the wall. So the momentum with which the car leaves the wall, that will be our final momentum. So it will be P final is equals to mv. Okay, so we have already collected the data there. We said the mass is what? It's 990 from where? From the statement. And then what do we have? We have a velocity there of what? Of 5 meters per second, but this velocity is going where? In the opposite direction of what? Of the 20 there. So we need to choose what? We need to choose direction, and then we need to decide which side we are going to take as positive, and then which side we are going to take as what? As negative. So I will take the initial direction of motion as what? As positive. So let us do that. Let us take the initial direction of motion as positive. In this case, what was the initial direction of motion? It was to the right. So I will take the right as what? As positive. It means that anything or any velocity that is moving where? To the left will therefore be taken as what? As negative. So what are we going to do? So any velocity that is going to the left will be taken as negative. In this case, the 5 meters per second is moving in which direction? To the left. So it means that my velocity will therefore be what? -5 instead of what? Positive. Negative 5 instead of the positive 5. So what are you going to do from there? You are going to take your calculator and punch in the 990 multiplied by the -5, so it will give you -4950 kilograms meters per what? Meters per second. So that is then the momentum with which the car leaves the what? The momentum with which the car leaves the wall. So it is leaving the wall at a velocity of 5 meters per second, but because we said the left will be negative, that is why our velocity is what? Is negative. And then for the direction, it is therefore 5950 kilometers per second. In which direction? Our direction is what? To the what? To the left. Okay. Then number 3, it says the change in momentum of the car. So what do we know about the formula of change in momentum? Its change in momentum is equals to what? P final minus what? Minus the P initial. So what do we have for the P final? We have already calculated the P final. It was given as -4950 minus, what was the P initial? It was given as 19,000 what? 19,800. Okay, so from there, what are you going to do? You are going to punch in this into your calculator to say -4,950 minus 19,800. What does it give you there? So for this one, I'm getting -24750. That is then kilograms meters per second. So remember, we said again, the SI units for the change in momentum will be the same as the SI units of what? Of the momentum. So what are the SI units for momentum? SI units for momentum are kilograms meters per second. Therefore, the SI units for change in momentum will also be what? Will also be the same. So for the direction, how do we write the direction now? We are getting what? A negative answer. So if we have a negative answer, we are then going to look at the direction. So what did we say? We are going to take the we said we are going to take the right as what? As positive. So if we are getting a negative answer, we are then going to write it as a positive answer, kilograms meters per second. So 24,750 kilograms meters per second. In which direction? It is going to be to the what? To the left, because we said whatever that will have that is moving to the left, it is whatever that we are going to have that is moving to the left, or whatever that we are going to have that will give us a negative answer, will therefore be in which direction? It will therefore be to the left. Okay, so if I am to allocate the marks for this question, for number 1, you'll get a mark for the formula, you'll get a mark for the substitution, and then the final answer with the correct SI unit and the direction. The same for this one, formula for the correct substitution. A final mark there with the correct SI unit and the direction. Again, for this one, we'll give a mark for the formula, we'll give a mark for the substitution there, and then a mark for the correct answer with the correct SI unit and the correct what? Direction. Okay, so now learners, I will give you 2 minutes just to think about this one, and then we can then do it together. So 2 minutes for this activity. Welcome back, learners. So if you have any questions, you can send your questions to the following WhatsApp number 063-508-1301. So if you have any questions, I will repeat the number. You can send your questions to the following WhatsApp number 063-508-1301. Okay, so let us have a look at this activity together. It says here, a learner with a mass of 1,2 times 10 to the power of 3 kilograms is traveling with a velocity of what? Of 15 meters per second. In which direction? To the left. That is very important. Then it says hits a wall, okay, and rebounds to the right with a velocity of what? Of 2 meters per second. So so there's the car. It's going in which direction? So the car has a mass. Mass is what? Is m. Is traveling with a velocity of what? Of 15 meters per second. 15 meters per second. In which direction? To the left. So we follow this arrow to the left. There is our left there, hits a wall. So after the learner hits the wall, rebounds. So rebounds in which direction now? To the right with a velocity of what? Of 2,6 meters per what? Per second. Okay, so it says here we need to calculate the car's change in what? In momentum. So what are you going to do? Firstly, we need to collect our data. From there, we need to check if we need to do what? Any conversions. So we have kilograms, we have meters per second, so we are not going to be converting anything. Then next, you need what? You need a formula. So you're going to look at your formula sheet there and look for the formula of what? Of the change in the momentum. So for the change in momentum, it's either you are going to calculate the initial momentum and the final momentum separately, or you are going to do what? You are going to use this formula, change in P is equals to P final minus P initial, where you are calculating the final and the initial momentum at the same time. So PF is what? Is equals to MV final, which is your final momentum, minus your what? Your MV initial, which is your initial momentum. Okay, so in terms of the mass, what do we have there? We have 1,2 times 10 to the power of 3. In terms of the velocity, what do we have? Okay, for us to write the velocity, we need to determine the direction. So remember we said that we are going to take the initial direction of motion as what? As positive. So if this car was moving to the left initially, we are going to take the direction of as positive. But if initially the car was moving towards where? Towards the right, we're going to take that direction as what? As positive. So right now, the car is moving in which direction? The car initially, it was moving to the left. So it means we are going to take the left as what? As positive. So if we take the left as positive, it means that we are therefore going to take the right as what? We are therefore going to take the right as negative. So what are we going to do from there? The final velocity. So initially it was traveling at 15 meters per second. So this is the initial velocity, and then after it rebounds, this is our final what? Final velocity. So the final velocity is given by what? The final velocity is given by 2,6. But remember, we are going to give this velocity what? We are going to give it a negative, because we said whatever that is going to move to the right hand side, the direction or the sign will therefore be what? Negative. Then minus the mass of what? 1,2 times 10 to the power of 3 multiplied by what? Multiplied by the velocity. So initially, the initial velocity was what? Was 15 meters per second. So we have a positive 15. Why a positive 15? Because we said we are going to take the initial direction, which is to the left, as what? As positive. So that is what we did there. So from there, you are going to take your calculator and multiply this. So you can either calculate it in portions, or you can then put the whole thing into your calculator. So I will calculate it in portions. So we have this 1,2 times 10 to the power of 3 multiplied by what? Multiplied by negative 2,6, which gives me 3,120 minus what? Minus 1,2 times 10 to the power of 3 multiplied by 15, which gives me 1800 there. So from there, what are you going to do? You will then take your 3,120 minus the 1800, and what does it give you? It gives me 21120 kilograms meters per what? Meters per second. So again, remember we said the SI units of the change in the momentum will be the same as the SI unit of your what? Of your momentum. So we have a negative answer there. So if we have a negative answer, we are therefore going to write it as a positive answer with exactly the same unit, but in terms of the direction, remember we said if we have a negative, then it means our direction is to the right. Our direction is to the right. So for this one, we'll get 1 mark for the formula, 1 mark for the substitution, and 1 mark for the what? For the correct answer. That is your magnitude with the correct SI unit and the correct what? And the correct direction. Okay. So Newton's second law in terms of momentum. That's the next one there. It says Newton's second law of motion. So in terms of momentum, it says the net or the resultant force acting on an object is equal to the rate of change of momentum of the object in the direction of the what? Of the net force. Then it says net force is equal to the rate. So when you talk of the rate, what are you talking about? You are talking about the time there, or the change in what? The change in time. So just to read again, it says the net or the resultant force. So there is the net or the resultant force. It says that is acting on an object is equal to what? Is equal to the rate. So the rate, we are talking about the time or the change in time, is equal to the rate of the what? Of the change in the momentum of the object that is in the direction of the what? Of the net force. So we have already spoken about what? About the change in the momentum. Then this is according to the examination guidelines. Again, it says we need to be able to calculate the change in the momentum when a resultant force acts on an object and its velocity. Okay, so and when its velocity increases in the direction of motion. Number 2, when its velocity decreases. And then number 3, when the velocity when it reverses its direction of what? Of motion. And then it says the net force acting on an object is in the same direction as the change in the momentum of the what? Of the object. So all of this we need to know under Newton's second law in terms of momentum. That is according to the what? According to the examination guidelines. Then we have impulse. So with impulse, it says you need to know how to define what? You need to know how to define impulse as the product of the what? Of the net force acting on an object and the time the net force acts on the what? On the object. So remember we said if we speak of a product mathematically, so then we are speaking about what? We are speaking about the multiplication. And then it says the product of what? Of the net force. So it is F net then, acting on an object, okay? And the time. So the product, so the multiplication of what? The multiplication of the F net. So net force that is acting on an object, and the time the net force will do what? The time the net force will act on the object. And then it says impulse is equal to the what? Is equal to the change in momentum. So this product of F net times the time is therefore equal to what? Is therefore equal to the change in the momentum. So we have already spoken about this one, the change in the momentum. Then it says you need to use the impulse momentum theory. So impulse, we have it here on the left hand side as F net change in time. Momentum theory, there is momentum on the right hand side to calculate the force exerted. So the force will therefore be represented by what? By the F net. The time for which the force is exerted, so that is our change in time, and the change in the momentum. So the change in the momentum is this one here that we just spoke about. for a variety of situations involving the motion of an object in one dimension and in the context of what? Of technology. So again, according to the examination guidelines, we need to know how to use this formula, which is the impulse momentum theory. Why the impulse momentum theory? On the left hand side here we have impulse, which is what? F net, change in time, and then momentum is where on the right hand side. So we need to know how to use this formula in order to calculate what? F net, change in time, and the change in the momentum there. So it says we also need to explain how the concept of impulse applies to road safety considerations in everyday life, for example, airbags, seat belts, crumple zones, and also the arrestor baits. So impulse, it says the product of the net force. So we just spoke about that. The product means what? Multiplication of what? Of the net force that is acting on an object, and the time the net force acts on the what? On the object. So product, multiplication of the net force that is acting on an object for a particular time. So it says, and the time this force is acting what? On the object. So therefore it says impulse is equals to what? F net multiplied by the change in time. Okay, so again the impulse momentum theorem. So impulse on the left hand side, momentum on the right hand side. So therefore the impulse and the momentum theorem. It says here the net force acting on an object. So the net force acting on an object is equal to the rate, that is when we talk about time, of change in what? The rate of the change in the momentum of the what? Of the object. Then it says F net is the rate of change of the momentum of what? Of an object. So rate, again we are speaking about time, rate of the change in P there of the what? Of the object. Okay, so it says impulse is a vector quantity and its SI unit is what? Is Newton. It's Newton second, not Newton per second, but Newton what? Newton second. So where's the Newton second coming from? The Newton is coming from the F net, and then the second is coming from the what? The second is coming from the time. So when you write down the units for the F net, you will have Newton, and then for the time you will have what? You will have the seconds. So we are saying impulse is what? Is a vector quantity. What is a vector quantity? We said vector quantity is a physical quantity which has what? Both magnitude and what? And direction. Then it says here, note that when calculating the change in the momentum, the SI units would be those of what? Would be those of what? Of momentum. And then it says an impulse will have the same value as the object's change in the momentum, but with a different what? With a different SI unit. Okay, so let us just repeat them. It says note when calculating the change in momentum. So when you calculate what? When you calculate the change in momentum is what? Is change in P. The SI units. So whatever SI units that you are going to get when calculating the change in momentum, the SI units would be those of what? Of momentum. What are the SI units of momentum? The SI units would be kilograms, meters per what? Per second. But then it says it says an impulse will have what? Will have the same value. So let's say that you calculated the change in momentum, and then you are now looking for what? You are now looking for the impulse. They are now saying that the impulse will have the same value as the object's change in the momentum. Same value means what? The same magnitude. So let's say magnitude was what? Was 40. But with a different what? With a different SI unit. What are the SI units of impulse? It is going to be Newton what? Newton second. Right. So As an example here, it says a 75 kilogram man and his car are suddenly accelerated from rest to a speed of 4 meters per second. As a result of a rare collision, the time taken for the collision is therefore what? Is therefore 0.3 seconds. Then it says here that you need to calculate the impulse where you need to calculate the impulse on the man. And then the next one says we need to calculate the what? The force that is exerted on him during the what? During the collision. Okay, learners, so before we continue here, I'm going to ask that we take a 2 minutes break, and then we can therefore continue with this example. Welcome back, learners. So if you have any questions, you can send your questions to the following WhatsApp number 063-508-1301. So again, if you have any questions, you can send your questions to the following WhatsApp number 063-508-1301. Okay, so let us continue. It says a 75 kilogram man and his car are suddenly accelerated from what? They are suddenly accelerated from rest. Okay, so remember, this is a keyword. So from rest would mean that we have a velocity of what? We have a velocity of 0 meters per second. Then it says to a speed of 4 meters per second as a result of a rear end collision. Okay, then it says the time taken for the collision is therefore what? 0.3 seconds. So it says that we need to calculate the impulse on the man. So what do we remember? We need to go back to the formula sheet and look for the formula of what? Of impulse. And what is the formula of impulse? Formula of impulse is given by F net change in what? Change in time. So that is your impulse, okay? But then you see that you are not given the what? You are not given the force there. Yes, you have the time. So what are you going to do to calculate the impulse? So you will therefore say F net change in time is equals to your what? Is equals to your change in the momentum. So that would therefore give you your impulse. So from there we are going to say P final minus what? Minus P initial. And then your P final is given by what? Is given by MV final minus what? Minus MV initial. So going back to the statement, remember we need to read carefully. It says we have a 75 kilogram man collecting the data. Then the 75 kilogram represents what? It represents the mass, and then accelerated from what? From rest. So that means that the from means that that is our initial velocity to a speed of, so there's your keyword, to a speed of 4 meters per second. That would represent our what? That would represent our final velocity. So in this case, it looks like it is going what? In one direction. So the initial velocity and the final velocity, they are all going in one direction. So what are we going to do from there? The next step is that we need to check if ever we need to be converting anything there. So at this point, the mass is given in kilograms, the velocity is given in meters per second, and okay, we don't need the time, but it's given in what? In seconds. So from there, what are you going to do? You substitute your mass of 75 kilograms, and then you substitute your velocity of what? Of 4 there. That is your final velocity. Again, you substitute your mass, and you substitute your what? Your initial velocity of what? Of 0. So from here you can see that the 75 times 0 will give you what? It will give you a 0. So it means that your focus is just on the 75 times 4, which is equal to what? Which is going to be equal to 300. Okay. So remember, if the question said you must calculate the momentum, then you are going to write the units of what? Of momentum. But because we are calculating the impulse, then we know that the SI units of impulse, the SI units of impulse are what? Are therefore Newton what? Newton second. So we are going to take the same what? The same magnitude as that of the momentum, but we're not going to take the what? The same units. So what are the units of change in momentum? Kilograms meters per second. But the question said we needed to calculate the what? The impulse. So what are the units of impulse? Newton second. So therefore we are going to write the units of what? The units of impulse. Okay. So again, if I was to give a mark allocation there, I would give 1 mark for the formula there, 1 mark for the substitution, and 1 mark for the correct answer with the correct SI unit and what? And the direction. So in this case, we were not given the direction, so we can therefore just say that it is going to be in the, so we can say in the direction of what? In the direction of motion. Why are we giving it direction? Because we said that impulse is a what? Is a vector quantity. What is a vector quantity? Physical quantity which has what? Magnitude and what? And direction. So magnitude is the 300. We have an SI unit and what? And the direction. Next question says that we need to calculate the force exerted on him during the what? During the collision. So how are we going to calculate that force? You need to go back to your formula sheet and look for the formula of what? Of the momentum and what? And impulse there. So what do we have now? We need to calculate, so let me write it properly. F net change in time is equals to what? Change in P. So we have now calculated the impulse, which was what? Which was 300, and then we are given the time of what? We are given the time of 0.3 there, and then we are asked to calculate the net force. So how are we going to calculate the net force? We can see that we have a 0.3 on the left hand side there, and then we can divide both sides by the 0.3. So when we divide then 0.3 divided by 0.3 on the left hand, on the right hand side, what do we have? We have a 300 divided by the 0.3. So that will therefore give us the what? That will therefore give us the F net of what? Of 1000. F net is what? F net is a force, so therefore the unit will be what? The unit will therefore be Newton. And then what are we going to write as the direction? It will be in the direction of what? In the direction of what? Of motion. Okay, so again, if I was to mark this one for you, I'll give 1 mark for the formula, I'll give 1 mark for the substitution there on the left, 1 mark for the substitution there on the right. I'll also give you 1 mark for the final answer with the correct what? Correct unit. We are dealing with the force, so the force will have a unit of what? Of Newton. And then also we are dealing with a force, of a force is a vector quantity, meaning that it will also have what? It will also have magnitude and the direction. So this is our magnitude, this is our SI unit, and then in the direction of motion, it therefore represents the what? It therefore represents the direction. Okay, so learners, we have ran out of time for today, and then what I will do is I will then give you homework. So I will give you some time to quickly take a screenshot on this one. And then you can also take a screenshot on this one. So thank you very much, learners, and I'm going to end with the quote for Nelson Mandela, which says that it is in your hands to create a better world for all who live in it. Thank you so much, learners. I will see you next time at the same place and at the same time. Thank you.